Hello, Avishai. Are you with me?
Yes, I am. Hello.
Great. You are the last presentation here. Have you changed your PIN code? I think that's the #1 question everybody is thinking about.
Yeah, I gave a fake one, of course.
Yeah, of course you did.
Yes, maybe I'll change the fake one to a better fake one next time.
Yeah, with more digits to really give Alan a big challenge.
Yes.
Yeah. So you're going to present microsegmentation for your network. So I leave you to it, and then we can take the questions afterwards.
Sure. Thank you very much. I hope everybody can hear me and see my screen. So I'm Professor Avishai Wool, AlgoSec CTO and co-founder. And this session, we're going to talk about microsegmenting the network in an application frame of mind. So I'm going to start with a motivating example, which really is an extension of what Thomas was talking about. I'm going to repeat a little bit of what he said. So we'll do that quickly. Talking about ransomware and the focus on lateral movement. Okay. So here's how ransomware works. The first computer gets infected somehow, and then we get into a cycle. Oops, hang on a second. This is what I want. We get into a cycle where the malware encrypts the local file system, and then it encrypts the network file systems that it has access to, and then it starts to move laterally. It looks for other computers on the network which it can exploit. Whatever it finds, it delivers the exploits to the next victim computer over the network and repeats. The cycle repeats until eventually some critical system gets infected and somebody picks up the phone and calls the ransomware author. Hopefully for the ransomware, people pay them the money. Not a good idea, better to restore from backups if you have them. But this is the business model. I'd like you to pay attention to this step of lateral movement where the exploits move over the network. This is something that we can think about. So if, everybody's favorite example, imagine you have people working from home these days with COVID. The first computer to get infected might be an employee's computer at home. So this is step 0. Not too much can be done there. We don't, as an organization, have too much control over that person's laptop at home. But what happens from there is that the malware makes its way laterally from the home environment to, let's say, the clock system that the employee has to check in with. And from there, they can make their way across the network to the procurement area, and then maybe to a financial database and encrypt something that's really important, at which point you face the unpleasant choice between paying up or losing data or restoring from backups. Okay, so these steps 1, 2, and 3, these are the ones that we want to take care of because these happen over our network. We are in charge of this network. We should be able to do something to limit these steps. This is where microsegmentation comes in. Basically, the idea is to reduce the attack surface. So at a very high level, the idea is to organize the network into segments, as small as you can make them. Lots of microsegments. So you define these segments to control all this east-west traffic. And then you activate traffic filters for traffic crossing between segments. So any type of traffic that wants to cross from segment 1 to segment 2 needs to go through a traffic filter. And that traffic filter should have restrictive policies on it saying what is allowed to cross that border. Well, this is the plan. Okay, so on the PowerPoint, it's really easy. All you need to do is to put filtering technologies all across all of these segment to segment boundaries, and you're good, right? So really easy. Took a few minutes to put together the slide. No, not a big problem. Okay, now this is not new. People have been thinking about this for years and years. It's not a new idea. Nonetheless, it hasn't happened so effectively. Why is that? Well, if you want to do this kind of segmentation in a traditional data center where you use firewalls as your filtering technology, that often requires making changes to the network. You need to maybe reassign IP addresses, routing changes, define VLANs, maybe, God forbid, actually pull wires from place to place in the data center, which means it's hard work. And this is why not many organizations have done segmentation at very granular levels, because it's a lot of hard work. So they define 2, 3, 5 segments and stop there. Okay, but this is a long time ago. Let's move forward. We're now in 2021. We have better technologies at our disposal. We can use software-defined data centers. And one of the things that software-defined data centers have is that they have filtering capabilities inside the network fabric. It's baked into them. So you don't have to go to all these difficult things that were necessary in the past. Those excuses are gone. You can basically use the filtering capabilities that you have in the platform. And practically all modern virtualized data center providers have this. So if you're looking at an on-premise data center and you're using Cisco ACI or VMware as your underlying technology, you can filter in the fabric. Also, if you go to the public cloud, Amazon, Azure, Google, they all have security groups and access lists and so on, filtering mechanisms that you can deploy. They're baked into the fabric, they're efficient. You're already paying for them, so you may as well use them. So the technology is there, you can use it. But technology is just the first step. You still need to configure it. It's good that you have it, so the excuses are gone, but you have to use it to get any value. So this is the next challenge. So the next challenge is to write the filtering policy. So what filtering policy should you write? You should write policy that naturally allows all the legitimate business traffic and nothing else. If you can do that successfully, then you're not breaking any traffic. You're allowing all that's necessary, but when the malware wants to jump across segments, then that's not legitimate business traffic. It's going to be blocked, hopefully. So to do this, to be able to write this policy effectively, you just need to know the intent of all the legitimate traffic in the data center so you can write policy allowing it. I'm assuming a brownfield situation where you have stuff working, and now you just need to write filtering policy allowing everything that's legitimate there. So how do you do this? Well, naturally, you have perfectly accurate records for all the application flows in your data center, documenting in machine-readable form what they are, what they're for, what's connecting to what and why. So you have all these records, you can just use it. It's really easy, right? Well, perhaps you work for a company that belongs to the type of company that has such accurate records. I, for one, have not met anybody that meets this category. But if you do work for such a company, then that's great for you. For the rest of us, you need to go through some kind of discovery. You need to find out, you need to detect what the applications are in your data center and what flows they have. And if we look at this more specifically, you need to detect all the network flows, and then you need to annotate them with the net application name indicating the intent. Why is this flow there? And then this is a often overlooked step. You actually need to aggregate and optimize them, because it's been our experience that if you gather this kind of information and find all the flows going through the data center, you're going to find a lot. You're going to find thousands and thousands of connections from IP to IP using some ports. One of our customers did this and came up with a number of 26,000 flows for a single application that they had in their data center. Just one, 26,000 flows. If you try to take that and push it into any of the technologies that I mentioned before, that's not going to work because it's too much. There are too many rules. You have to aggregate them and into something that is a much smaller number of rules that fit into the filtering technology and still allows only necessary traffic and not other things. Once you do this, you can place them in the filtering technology of your choice, and then you have actually deployed a microsegmented architecture. So how do you do this? Where do you get the data? So you could get the data, the raw data, from something like NetFlow. You can configure your routers or your switches or your VMware infrastructure to emit NetFlow, and AlgoSec Auto Discovery can digest that and produce everything automatically. You'll see this soon. Or better, you could use Guardicore. Guardicore does this discovery. It has this information, and AlgoSec can integrate with Guardicore, and we can feed the information from Guardicore into AlgoSec Auto Discovery and achieve the same kind of discovery, but better, because Guardicore also annotates the information about what is going on there. So we get more information and you get more value. Either way, it's in auto discovery. From there, it's imported into AppViz, which does this aggregation and optimization step. And once you do this, what you have is microsegmentation know-how. You actually discovered what your network is, and you discovered what connects to what and why. You have your annotation, and then you can use that in the future when you're managing changes later on, when new versions of the application come out and you need to modify the filtering traffic, both for east-west traffic and also for north-south traffic, because traffic needs to get out of the data center and into the data center, and sometimes it needs to cross additional filtering technologies, firewalls, routers, etc., elsewhere in the network. So you need to use this knowledge that you've created through the discovery process to control and to automate your ongoing network management requirements. Okay, I'm just going to show you one little demo in the slides so that you get a feeling of what I'm talking about. So this is the AlgoSec user interface. You can see auto discovery here. If you activate that, you're going to see this long list of thin flows. This is coming from NetFlow. If it comes in from Guardicore, there's going to be more. Lots and lots of thin flows. What AlgoSec does, first of all, is it organizes these flows into what we call business services based on shared IP addresses and timing. So you can see that this IP address here in the middle receives connections from clients and also connects as a client itself to some other servers in the back end. And apparently the connections here and here are close enough in time that the system realizes that it's all doing the same process and puts all of these servers and all of these flows into one business service because they're all serving one purpose. This information gets imported into AppViz, where this aggregation into fat flows happens. And here you can see the aggregated flows. You can see multiple sources and multiple destinations. Sometimes there are subnets here. This gets imported into AlgoSec AppViz, and there you have the understanding of the commercial banking application. This is the sketch of its flows, and there's a lot that you can do here, such as controlling future changes. Suppose you want to make changes. Now I'm looking at the billing application. Suppose you want to add to the billing application connectivity from, let's say, the invoice server to the customer database using PostgreSQL. There's a new version, you need to add this connectivity. If you do it in AppViz, what happens is it creates a change request, and AlgoSec automatically discovers the systems that you need to modify. In this case, we have 2 Ciscos and a checkpoint. You may ask, okay, so how does AlgoSec know? Well, this is the Find Out Why button. If I click on that, you can see in one screen really the core capabilities of the AlgoSec technology. AlgoSec is able to simulate the network both from an IP routing level and from a filtering level across the whole network. And here we have traffic, let's say, being emitted where the green flag is, going in these directions. And inside that network, this is where the Guardicore system lives. It's protecting the data center over there. But this traffic also needs to go and cross other places where these other filters exist, and some of them need to be changed because they're blocking the traffic as well, legitimate traffic. And AlgoSec is able to handle that and assist in this management. one of the things we do is compliance awareness. So when you make such a change request, AlgoSec checks if this change request is going to trip up any risks or not. In this case, no risks were found, so it's okay to just approve. And if this is approved, then AlgoSec actually creates what we call work orders, indicating how to implement this change on a particular device. In this case, this is for a Cisco device. This is how to write the rules, and there's a button here that allows AlgoSec to push the changes into the device based on the vendor's APIs. So to summarize, what you have seen is that, first of all, microsegmentation is key to tight network security, especially in these days of ransomware. That software-defined networking enables microsegmentation, but it doesn't mean that all challenges are gone. You still need to discover the intent. You need to define segments. You need to define the initial policy. And once you do that with the assistance of Guardicore and AlgoSec, you've gained the knowledge of how your organization works, and you can, in an ongoing maintenance phase, easily and automatically control both east-west traffic and north-south traffic. And with that, my presentation is finished for today, so I can hand it back to the host. Thank you for your attention.
Thank you, Avishai. Thank you. You know what? When we are doing projects around CI/CD pipeline integrations, this is becoming one of the biggest topics because, you know, without having this complete view, it becomes really hard to automate changes. And you also want to document the changes. Even if you automate them, you want to have them, you know, in a central place, knowing which application is actually using this firewall change.
Right.
You know, does that also align with your products that you're seeing?
Absolutely, yeah. I didn't have time, of course, to go into all the capabilities, but of course, our workflow product documents every change. There's an audit trail. You can go back and find out who did what and why. We also put an annotation on the rules inside the firewall, so that if you know, a year later you're looking at a firewall and you're asking yourself, why is this here? The rule itself is going to give you a clue. It's going to say this came from change request ABC that Marcus initiated and Avishai approved on 14th of September, and this belongs to application billing. All that's going to be on the rule, and it becomes a link which you click on, and you can unravel the whole history. There's a lot more where that came from. So audit capabilities and so on, that's definitely it's one of the strengths of the AlgoSec solution.
Yeah, I completely agree with you. And my take on it is that if your company is thinking about doing CI/CD implementation of the network infrastructure, that's going to be really, really hard without having this kind of overarching tool that is visualizing your infrastructure. I mean, we can use the APIs and AlgoSec to implement it automatically, but we still need the data. Thank you, Avishai. And now we're going to leave over to Alan again and get some more magician. Thank you, everybody.